Hello everybody and welcome back to the grade 8 Gauss contest from the year 2001. We're up to question number 22, which is one of the last few questions on the paper. Should be one of the harder questions because it is worth more marks. And question 22 says 64 white 1 by 1 by 1 cubes are used to form a 4 by 4 by 4 cube. Okay? Which is then painted red on each of its 6 faces. They have a question that's sort of like this every couple years. I like it. It's a nice sort of spatial reasoning question. This large cube is then broken up into the base 1 by 1 by 1 unit cubes. Each unit cube is given a score as follows. So if you have 3 red faces painted on you, you're a score of 3. 2 red faces, you're a score of 2, 1, 1. And if you have no red faces, that would have meant that you're sort of on the interior of this 4 by 4 by 4 cube. You have a score of -7. The total score for the 4 by 4 by 4 cube is, so when they say total score, we're going to figure out the scores of each of the individual unit cubes and add it up in total. That's what they're looking for here. So how about we draw a picture and better understand how this 4 by 4 by 4 cube is painted, and maybe we can start counting. Well, which ones get score 3, which ones get score 2, and so on. Okay? So, I have 64 unit cubes. And I'm not going to draw this bigger cube transparent. I'm just going to draw it as is. And we're going to mark it and divide it into its 4 by 4 by 4 sections. So there we've got a 2 by 2 by 2. Because it's a power of 2, we can really nicely draw it very quickly. We see our cube beginning to take shape. Alright, that's good enough. We don't need to bring out a ruler or anything like that. So the whole thing is painted red on the outside. So some cubes, some of the little 1 by 1 by 1 cubies, like for example this one right here, have 2 faces red. Some of them, like this one right here, then I have only 1 face red because only one of its faces face the outside. Some of them, which aren't pictured, are going to have 0 faces painted red. That's because they're entirely in the interior. And a couple, in fact every single corner, is going to have 3 red faces, and that means it has a score of 3. All right. So if we want to figure this out, let's give names to them. So let A equal the number of cubes with 3 red faces. We'll let B be the number with 2 red faces. C be the number with 1, and D be the number with no red faces. Okay? If I were able to figure out what A, B, C, and D are, then the total score is a simple matter, total score, not total sore. The total score then becomes a very simple matter. It'd be 3 points for everyone in A, so 3 times A, plus 2 points for everyone in B, plus 1 point for everyone in C, plus negative 7 points for everyone in D. So now we just need to go about figuring out what A, B, C, and D actually are. Okay, and our little picture is going to help us. We can see immediately only the corners are going to have 3 red faces. How many corners are there? Well, every cube always has only 8 corners. So already we can see A is equal to 8. So which of these cubies in what positions get 2 red faces? Well, it's not the ones that are on the corners, but they are ones that are on 2 of the faces of the bigger cube, like we have here. So the edge pieces have 2 red faces. Well, how many edge pieces are there? Well, any cube has 12 edges, and the edges have 2 cubes. We have 2 cubes per edge. So we're going to have 24 cubes with 2 red faces. And C, we need to figure out how many have 1 face. And then once we have those, once we have the number with 3, the number with 2, the number with 1, we know the total number of cubes, so we can just figure out D by saying it's 64 minus A minus B minus C. Minus all the other cubes that happen to have just a little bit of red on them. The cubes that are left over must be D. Or if we wanted to, we could reason it out. I'll probably verbally reason it out as I do the calculation I just illustrated. Now, the pieces that get only 1 are the ones that aren't edges, aren't corners, but still lie on a face. So the face pieces have 1 red face. How many faces does a cube have? Well, it has 6 sides, so 6 faces. And there are 1, 2, 3, 4 cubes per face. Okay. So that gives me a total of C is 24 cubes. Now if you wanted to, use cubes left over. If you wanted to, you could reason that D is all the cubes that are solely in the interior. And you could probably, so there's 1 cube on each corner, there's 2 on each edge, there's 4 on each face, there's going to be 8, 2 to the power of 3 on the interior. So we should get D is equal to 8, but we can also just calculate it as the cubes left over. So 8 have 3 red, 24 have 2 red, and 24 have 1 red face. That's going to be 48 plus 8, that's 56. So 64 minus 56, that's going to be 8. If you need to grab your calculator, that's what it's there for. So now that we know A, B, C, and D, we can calculate our total score. Once again, I'm trying to write total score, and I don't know why I'm doing that. So we had a simple formula for that. It's 3A plus 2B plus C minus 7D. Well, we have these values. So that's 3/8 plus 2 times 24 plus 24 minus 7 times 8. So 3 times 8, that's 24. Plus 2 times 24, that's going to be 48. Plus another 24. And 7 times 8, So we're going to subtract off 56. Okay. And if you need to, again, grab your calculator to get this all worked out. 24 plus 48 plus 24 minus 56. And when we do that calculation, either in our head or on the side or with our calculator, we get an answer of 40. So the 4 by 4 has a score of 40. And that was one of the answers. It was the lowest one. It was A, 40. And that about does it for question number 22. So we're going to take a look at question number 23 in the next video, and I'll see you guys then.